Hello and welcome back everyone. This is the Quest Master Shreyansh on the Quest Introduction to Rust. In this specific subquest, we'll be talking about types. Recall from the previous subquest, a variable is a box which holds some value. The more formal definition would be a variable is a box which holds some value of a specific type. The way you annotate a variable is you add a colon followed by the type you want in front of its name. In this case, we'll give it a i32 type, which is a signed 32-bit integer. An integer is a number which does not contain a decimal. Just as a sanity check, we'll also print this out in a way we are quite familiar. We'll print this out using the println macro where we'll say the value of the variable is something and we'll bind it to x. Let's run this and we see that the value of the variable is 5. What I'm doing here is that I'm writing some code which will print out the type of any variable I want. You don't need to worry about how it works right now. Let's check if everything works as expected. We'll call x.printType, which in this case, because it is explicitly annotated, should be i32. Let's move on to our terminal and let's run this. We see that the type is i32, which means it works. Now, what would happen if I were to remove the i32 declaration? So let's try removing this and we'll run this code yet again. So in the terminal, cargo run, and we see that the type is i32 yet again. This is because of something we call type inference. The way type inference works is that the Rust compiler automatically assumes the type of a variable based on how it's being used, where it is being used, and what you want to do with it. In this case, the compiler decided that i32 is the best type which we can give to the x variable. Let's talk about something called dynamic typing, in that how variables can automatically change their types based on what you assign to them. In this case, x starts as a number, we'll print out the value followed by the type, which in JavaScript you do with something called the typeof operator. Let's not forget to call this function later on. And following this, what I'll do is I'll reassign the variable x to something like a string, let's say hello world, and we'll print out the value as well as the type again. Using the same notation, this time I'll just change the formatting directive. Let's go into the terminal and let's try running this, and we see that the value of x is 5, hello world, the number type and the string type has changed accordingly. Let's try doing something similar in Rust. We have a variable x, let's mark it as mutable, and let's try changing it to, let's say again, a string. And what you will see that it gives an error, expected integer found a string slice. Why is that? That is of something called static types, which means that you cannot change the type of a variable once you've declared or defined it. So just as a recap, you annotate the type of a variable using the colon syntax. You add the colon after the name of the variable followed by the type you want. So let's talk about how numbers are represented. In this case, I have an i8, which is an integer of 8 bits. It's a signed integer of 8 bits, which means that the first bit is used for sign. The next 7 bits are used for the number itself. So the sign can be 0 or 1, depending if it's a positive or a negative integer. Because i8 only uses 7 bits to represent the number itself, it can only have a value from minus 128 to positive 127. You might be wondering why not positive 128 as well. That's because of something we call the 2's complement, something which is outside the scope of this quest. Let's try this out in practice. I'll change the value 5 to 128 for an i8, and you will see that it gives us literal out of range for an i8, which means that 128 isn't something which i8 can represent. We can fix this by making this an unsigned 8-bit integer. Now, if we were to remove the first bit, we now get 8 bits to represent our number itself, which means we can represent from 0 all the way up to 255. Now, what if you wanted to represent a number which contains a decimal? Let's try figuring out the type for this specific type of number within Rust. We already have the function, so let's call x.printType, and we'll move on to our terminal where we'll call cargo run. And we see it as a f64 or a 64-bit floating point number. Rust gives us the option of using either f32, which is a 32-bit floating point number, or 64, which is the default. Characters within Rust represent a single UTF-8 character, which means that they can either be a full ASCII character or they can contain anything which is permissible within the Unicode standard. So in this case, we have a C followed by the sign for a section. What if you wanted to represent yes or no? In other words, a Boolean. Let's try declaring a variable called x and we'll give it the value of true. We also have the print type function, so let's call that and let's run this code. We see that the Boolean type within Rust is called bool. Booleans are mostly used for control flow and conditionals, something which we'll cover in a later subquest. Right now, we have two conditionals. If x is true, then print out that text. If y is true, print out that text. In this specific case, since only x is true, we'll only see the line 19, which is x is true. And when we run cargo run, we, as expected, see x is true.